Test. Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stats and math at University of Toronto. Today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. Okay. So our first question today is asking us, what is root 65? Okay, so now let's copy down the question first. So, what is root 65? Alright, so first, we can always express this by its product of its prime numbers. So whenever we come across a question asking us what is root something, so we always express the value as a product of its prime factors. So let's write down the keyword. So product of its prime factors. Okay, so we know that 65 is equal to 5 times 13. Yep, and we know that 5 and 13 are prime numbers. Okay, so now we can go to our second step. We can apply the radical root. Okay, so we have root 65 is equal to root 5 times 13. And in this case, we cannot further exact any root since we don't have a pair of same factor. So let's mark it down here. Cannot further extract any root since we don't have a pair of same factor. Alright, so our last step, we can write our conclusion. So therefore, root 65 is already in its own simplest radical form. Yeah. And let me just explain this part a little bit more. So what I mean by they don't have a pair of same factor is that recalling the property, if we got a root square of, let's say, a squared, and the answer for this part would be a, right? So for example, let's say if we have root 3 squared, and then we take the square root out that, we're gonna get 3, right? So let's say we got a root square of 100 squared, and then we'll get 100 as our answer. Yeah, so that's what I mean by a pair of same factor. Because this can also, this can also be written as root 3 times 3, root a times a, and root 100 times 100. Yeah. Okay. And yeah, so root 65 is already in simplest radical form. And now let's look at the Janine Tutor's answer for the second part. So it says we can still estimate the value of root 65 without using any calculator. So in this case is that we need so whenever we are asking to convert this root 65 into a decimal form, and that should be the method we're going to use. So we know root 65 lies between two perfect square roots, which are, let me write it down here, which are root 64 and root 81. And the reason why we're picking these 2 points is because root 64 is actually 8, and root 81 is actually 9, because 9 times 9 is equal to 81, and 8 times 8 is equal to 64. So therefore, we can represent that on a horizontal line, which is 8, 9, and let's say that's 8.5. So this part is also root 64, root 81. And we know that 65 is what we're looking for. And let me write this down. So, wait. Yeah. Okay. So, root 65 is what we want. And 65 is just only 1 unit away from 64. And 16 unit away from 81. Yeah. So based on the plotted points, we can estimate the root 65 is between 8.0 and 8.1. So let's write 8.0 to 8.1. Yep. So let's try 8.01 square. So 8.01 square. So that should be equal to 0.1 square. So 64.16.1, and then we keep calculating 802 square, which is 64.3204, and all the way to 8.06, 8.06, which is 60.9638. And 8.07 square is equal to 65.1249. So now we realize that our second to the last product is the closest to 65, so we can conclude our answer. So therefore, root 65 is approximately equal to 8.06. Yeah. Okay. Oops, and that is 8. Yeah, so that's all we got for this part. Yeah, so let's leave a comment. Solution is correct. Good job. Okay, so let me zoom in a bit. Right. So the question is asking us what are the properties of parallelogram. Okay, so let me write it down here. Properties of parallelogram. Okay, so first, let's draw a parallelogram. Oops. And that's L, N, and K. Okay. So let's list the characteristic or say the properties of a parallelogram. So properties. Okay. So the first one will be opposite sides parallel. Yep. So from the figure, we can see that the line LK and the line MN are parallel to each other. And same thing, ML is a parallel to NK. Yep. So if we present that on a graph, it will be LK is parallel to MN, and LM is parallel to KN. All right. Okay, so that would be the first property. Coming up, the second one, we have opposite sides are equal in length, which is just simply means LK is equal to MN, ML is equal to NK. Yep. So not only they're parallel, they're also equal in length. Okay, so the third property will be the opposite angles are equal. And what I mean by that is angle measurement of angle M is equal to measurement of angle K, which is right here. And also the measurement of angle L is equal to the measurement of angle N. Okay, and then we have our sum property, which is sum of all interangles are equal. Oops, oh, my bad. Interangles is 360. Yeah, so if we want to present that in letter, it would be measurement of angle M plus angle L plus K plus N is equal to 360. Yep. And besides that, we have the consecutive angles. Yeah, which are just simply means angles next to each other. So consecutive angles are supplementary. Yeah. So which means they add up to 180. Yep. So in our case, it will be M plus L is equal to 180. So get rid of the yellow part first. So M plus the measurement of M plus the measurement of L is equal to 180. And the same thing, measurement of L plus measurement of K is equal to 180. So same thing for K and M as well. So let's write it down here. So L plus the measurement of K is equal to 180. And measurement of K plus measurement of N is 180. And M plus M is equal to 180 as well. And next will be if one angle is right or is 90 degrees, then all angles are right. And in this case, we're actually having a rectangle. Because in rectangle, every single interior angle is 90 degrees, or is right. Okay? So, oh, and next, I think that is our final property, is that the diagonals of a parallelogram bisect each other. Okay, so let's copy down the graph, or let's just use the graph we have here. Okay, so if we draw two diagonal, I'm gonna use black and pink to represent the two diagonals, and then because they bisect each other, so this part is equal to this part, and this the left triangle part is equal to the right triangle part. So I think that's all we got for this question. So let's leave a comment. Solution is correct. Okay, so next we have the 6 trig functions. Okay. Okay, so let's write it down here. 6 trigonometry functions. All right. So there are 6 main trigonometry functions, and these trigonometry functions relate to the side of a right triangle of an angle. And so first, let's just define some terms that will be useful to indicating this question. So we have a triangle right here. I mean a right triangle. Okay, so let's call that oops, this should be A, B, and H. And let's say we got this angle at theta degree. Okay, so let's first define what these are. Oops. Okay, so theta, which is our angle. Yep. So this is a measure of angle intercepted by the hypotenuse and the leg of a right triangle. Okay, so intercepted by the hypotenuse and the leg of a right triangle. Okay, so and then we have our H, which is right here. And we'll just talk about the theta. So H is the it is representing hypotenuse, and which is the longest side of the right triangle. Okay, and coming up, we have our A, which is our adjacent, in this case, the adjacent. Yep. So this is a leg that form the angle with hypotenuse. I'll just write HYP as a short form of hypotenuse. And last we have our B, which is opposite side. So this leg is not connected with the angle. So not connected with the angle. All right. Okay. So let's go back to our 6 trig functions. And let's just copy down the graph to the next page. Okay. And put it on the side. Okay. So the first one will be our sine function. Sine function. Okay. And so this related the angle, the opposite side, and the hypotenuse. And the relation is sine. We are SIN as a short as a symbol for sine. So sine theta. That means due to respect of theta, this is equal to opposite over hypotenuse, which is in our case would be B over H. Okay. Yep. And our second one would be the cosine function. And let me see. Yep. So it is. We write COS as a symbol for cosine. So cosine theta is equal to adjacent over hypotenuse, which is A over H. Okay. So the only difference between cosine and sine are the numerator part. So one is opposite and one is adjacent. Okay. So coming up, we have our tangent function. All right. So this related to the angle opposite side and the adjacent side. So we write, oops, change the color. We write TAN as a symbol of tangent. So tangent theta is equal to sine theta over cosine theta. And if we just substitute what we have earlier, we'll get B over H over A over H. And by simplifying this, we'll get B over A. Okay, so that's all we have for this. And then the last 3 functions are just the reciprocal of these 3 functions. So reciprocal. Okay. So let's count. Number 4 will be the cosecant function. Cosecant function. Yeah. So this is the, let's write it down here. That is a reciprocal of the sine function. So reciprocal of the sine function. Which is represented by the symbol CSC. So cosecant theta is equal to 1 over sine theta. Yeah, and recall sine theta is B over H. So if we want to take the take the reciprocal of that, it's gonna be H over B. Yeah. So we just switch the position of numerator and denominator. All right. So number 5 would be the secant function. Okay, which this is a reciprocal of the cosine function. Okay, so we will have SEC theta is equal to 1 over cosine theta, and recall cosine theta is a over h, so the reciprocal will be h over a. Okay, and our last one will be our cotangent function, which is the reciprocal of the tangent function. So cotangent theta is equal to 1 over tangent theta, which is equal to a over b. Okay. Yep. So those are all the 6 trig functions, 6 basic trig functions we have. Yeah, and when you're memorizing this, I suggest you memorizing them by pairs. So let's say we got sine theta is equal to b over h. So the cosecant function, which is a reciprocal of sine function, will be just the h over b. Okay, and for cosine theta, it is a over h. So the secant function just gonna be h over a, and for tangent is equal to b over a. So where the cotangent is just gonna be a over b. Okay, so that'll be the answer for this question. Let's leave a comment there. Oops. Just need to charge my computer real quick. Yeah. So I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, please visit the links in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from OneClass.